Find the extrema of f of x equals 2 sine of x minus cosine of 2x on the interval 0 to 2 pi. So let's think about what are candidates for where the extrema, or the maximum and minimum values, could possibly occur. So these extrema, let's say possible locations of the extrema on a closed interval. So here we have the closed interval 0 to 2 pi. So extrema could happen at the left endpoint, which in this case is 0. Could happen at any of the critical numbers, if there are any critical numbers, or could happen at the right endpoint. So we'll have to test the value of the function at 0, the value of the function at 2 pi, and the value of the function at any of the critical values. So remember, critical values or critical numbers, these are places where, so critical numbers, these are places where the derivative equals 0 or the derivative is undefined. So we'll have to find the critical numbers, which means we'll have to find the derivative of the function. So f prime of x is equal to, so we're taking the derivative of 2 sine of x minus cosine of 2x. So we have two terms. The derivative of 2 sine of x is 2 cosine of x, and then minus, let's separate this so it doesn't blend in with our work. The derivative of cosine of 2x is, well, the derivative of the cosine function is the negative sine function, and we have to apply the chain rule here. So that's negative sine of 2x times the derivative of the inside, which is 2. Or we can rewrite this as 2 cosine of x plus, minus makes a plus, and we have 2 sine of 2x. So, well, we know this function is never, or the derivative is never undefined, because the cosine function and the sine functions, the domains are both all real numbers. And so to find the critical numbers, we set this derivative equal to 0 and solve. Now the first thing we see is, well, we have the cosine function has an angle or an argument of x, and the sine function has an angle of 2x. So since those aren't the same, that causes some problems, but we have the double angle formula for sine, and we know that the sine of 2x is equal to 2 sine of x cosine of x. That's the double angle formula. So we could apply that to the sine of 2x here. So we'll have 2 cosine of x plus, well, we already have a 2 here, and there's a 2 from the double angle formula. So 2 times 2 is 4. So we'll have 4 sine of x cosine of x is equal to 0. So now at least all the trig functions have the same angle or the same argument, and now we could solve this. And it looks like each term has a cosine. So there's a cosine of x here, a cosine of x here, so we could factor out that cosine of x, and we could also factor out a 2 because there's a 2 and a 4. So if we factor out a 2 cosine of x, we're left with 1, because this whole 2 cosine of x was factored out, and we're left with a plus 2 sine of x. Okay, so now we have a product of 2 factors equaling 0. So that tells us either 2 cosine of x is equal to 0, or 1 plus 2 sine of x is equal to 0. And we're only looking on the interval 0 to 2 pi. So the cosine function is equal to 0 when x is equal to pi over 2 or x is equal to 3 pi over 2. And over here on the right, if we solve for the sine of x, we subtract 1 from both sides and then divide by 2. We're solving when is the sine of x equal to negative 1/2. Right? And that happens when x is equal to 7 pi over 6 or when x is equal to 11 pi over 6. Now these are your critical numbers. Critical numbers. So your extreme values, your extrema, could only occur at, well, if we're looking at extrema on a closed interval, your extrema could only occur at either endpoints or critical numbers. And so we'll test those. Okay, so your left endpoint is 0, your right endpoint is 2 pi, and your critical numbers are pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. Okay, so we need to plug these values back, not into the derivative, but into the original function. Okay, and our original function is up here, the 2 sine of x minus 2 cosine of x. So if we plug in 0 for x, so 2 times the sine of 0 minus the cosine of 0, well, the sine of 0 is 0, and the cosine of 0 is 1. So that will give us a negative 1. And if we plugged in 2 pi, same thing will happen. The sine of 2 pi is 0, and the cosine of 2 pi is negative 1, because if the angle is 0, if the angle is 2 pi, well, in this case it would be the cosine of 4 pi. In both cases, we have the same value, so that's also a negative 1. Now, if we plug in pi over 2, well, the sine of pi over 2 is 1. So 2 times 1 is 2. And the cosine of pi over 2, well, in this case, it's the cosine of pi. Because if we plug in pi over 2 for x, then we'll have the cosine of 2 times pi over 2, the cosine of pi. So let's say, let's write this out. 2 times the sine of pi over 2 minus the cosine of pi. So that's 2 minus a minus 1, or 3. And if we plug in 3 pi over 2, then it's 2 times the sine of 3 pi over 2 minus the cosine of 3 pi. Which would give us a negative 1. So the sine of 3 pi over 2 is negative 1. And so we have 2 times negative 1, which is negative 2. And the cosine of 3 pi is a negative 1. So negative 2 minus a minus 1 is negative 1. And if we plug in 7 pi over 6, that's 2 times the sine of 7 pi over 6. And the sine of 7 pi over 6 is negative 1/2 minus the cosine of 2 times 7 pi over 6, or 7 pi over 3. And 7 pi over 3 is the same as pi over 3. And the cosine of pi over 3 is 1/2. So when we plug in 7 pi over 6, we get negative 3 over 2. And finally, 11 pi over 6. So we have 2 times the sine of 11 pi over 6 minus the cosine of 11 pi over 3, which is the same as, well, an angle of 11 pi over 3. Let's see, 3, 6, 9, 12. So that's the cosine of 5 pi over 3. And so that gives us, if we plug in 11 pi over 6, again, that gives us a negative 3 over 2. So now, the extreme minimum is the smallest y value, which looks like it occurs both here and here. So our minimum, our extreme minimum, is the y value when x is either 7 pi over 6 or 11 pi over 6. So our minimum is negative 3 over 2. And our maximum value looks like occurs at when x is pi over 2. So the maximum value is 3. Okay? And so here are our extreme values, or our extrema, of the function 2 sine of x minus cosine of 2x on the interval 0 to 2 pi. And now, I know it doesn't ask for this in the directions, but we could probably come up with a pretty accurate graph of this function just based off of this information. Okay, so we're going 0 to 2 pi. So let's say pi is about there, and that's pi over 2 and 3 pi over 2. So we know that when x is 0, the y value is negative 1. And when x is 2 pi, the y value is also negative 1. Again, when we have x is equal to pi over 2, our y value is up here at 3. And when x is 3 pi over 2, our y value is down here at negative 1. When x is 7 pi over 6, so that's just past pi. Pi is 6 over 6, so 7 pi over 6 is about right here. Our y value is negative 3 over 2, or negative 1.5. So maybe down about right there. And when x is 11 pi over 6, we're also at negative 3 over 2. So it looks like if we just connect these dots with smooth curves, we know there's a critical value here. It's a maximum. So that's the maximum on the interval. Then we have this minimum at negative 3 over 2. And then we have a relative maximum, relative minimum, and the endpoint. So it looks like something like this. Now we'll talk about later in this discussion later about how to come up with very accurate graphs of the functions based on what the derivative tells us and also what the second derivative tells us. So it's not really in the scope just yet to graph functions, but in this particular case, it looks like we were able to come up with a nice graph of the function based off of the value here when we plugged in the critical numbers and the endpoints into the original function. Okay, that about does it for this one.